and welcome to Cloud DevRel Talks by DevRel, sorry. This is the week 4 edition for Next OnAir, where we'll be covering security. I am here with Yoshi Yamaguchi, and my name is Ian Lewis. We'll be your host for today. And great, so let's get started and jump over the slides. So today we're going to start by just giving a recap of our of the sessions that are coming out this week and the keynote, and we'll be doing that as well as having a couple of sessions on the security topic. And this is this particular event is a event for developers. So for folks who are technical practitioners, folks who are generally technical. So we're going to recap some events or some of the sessions and provide sessions that are geared towards folks who want to hear more about the technical capabilities of GCP. So just to get to jump into our agenda, so we're going to just give a little bit of introduction. So we've covered that partly, but I want to introduce my co-host as well as myself. So I'm Ian Lewis. I'm part of the developer advocacy team at Google for Google Cloud, and I cover mostly security and containers and Kubernetes. And I have with me Yoshi Yamaguchi, who's one of my colleagues in Japan. I'll let him introduce himself.
Hi, I'm Yoshi Yamaguchi. I'm also a developer advocate based on Tokyo office. My focus area is on observability, but today I'm going to give a recap of some sessions from the security from the perspective of the general engineers.
Awesome. Yeah, so we're going to be going back and forth a little bit, covering some of the top session picks from this week. But I want to start by giving a little bit of a recap of the keynote. And this was done by Sunil Poti and along with Vint Cerf. So it was really nice to see Vint Cerf as part of the keynote. But what they covered was a bunch some fairly high-level concepts. So it wasn't a terribly technical presentation, but it did cover kind of some of the background and context for some of the content that came out this week. So one of the things that was covered was some of the changes that have happened recently. Things like because of COVID-19 and many of the changes and challenges folks have had. Many companies have had to accelerate their digital strategy, and that's a little buzzwordy, but basically what that means is that folks have had to do a lot more stuff online and digitally, and so that kind of changes the landscape in terms of like what sort of things they need to handle from a security standpoint. A lot more folks are working from home, and so there's a lot more challenges of how do you secure things like the communication that they have as part of their normal working, how they work every day. And so some of the things like that were mentioned were things like Beyond Corp and some of the features of GCP that we're going to be talking about a little bit about more in detail because they had individual sessions. But some of the actual products that we have in GCP are geared specifically at these type of challenges. Another thing of note was the presentation by Vint Cerf, which talked about confidential computing, which is really important and interesting because it allows users to run workloads inside of GCP that Google doesn't have access to. So essentially, those get run in an encrypted way inside of essentially like an encrypted enclave in memory where the keys are stored in hardware that Google doesn't have access to. So this is something that allows folks to run things that are that have to deal with private data or things of that nature that need to be confidential, but at the same time can take advantage of Google infrastructure. So those were some of the major points that I thought were really interesting from the keynote. You can obviously check out the full keynote on the website. So let's move on to our actual picks from the sessions this week. And I'll go first myself. The first one that I wanted to kind of pick up and talk about was the session Security 212, which was to take control of security with Cloud Security Command Center. And Cloud Security Command Center is really one of the interesting features of GCP that I've been working with a lot recently. And what this Security Command Center is essentially a single pane of glass that allows you to see all of the threats and vulnerabilities and issues that you might have with projects across GCP. So this covers like multiple projects within a full organization. So if you imagine your entire company has many, many different projects, you want to have a single pane of glass to be able to see, essentially a single UI to be able to see all of the security issues that might be happening across all of those projects. Typically what folks are doing is they have like a security team or a SOC team, security operations center that deals with vulnerabilities or active attacks on their infrastructure, and so they want to be able to see these type of things all in one place. And Security Command Center really helps you out by having a bunch of different scanners and detectors that scan for issues in your GCP projects, and then surface these the things that it finds as findings in Security Command Center. And so there's a number of these different types of detectors. Some of them are focused on what we call vulnerabilities, which are essentially issues with infrastructure that are not urgent in the sense that somebody is attacking the infrastructure, but they're potential issues that you might want to fix in order to strengthen your security posture. So that might be something like, closing firewall rules or improving, the security of a particular, like, having an open SSH port or something like that. And so that's one set of aspects of the Security Command Center, but also it can cover things which are active attacks. So some of the detectors are like the container threat detection, which will detect if suspicious binaries are being run inside of a container, and surfacing that as a finding in Security Command Center, and then allowing you to take steps in order to mitigate and remediate that. So these findings are basically can be handled in a number of different ways, and one of those ways is to have it be handled by a person, or you can do things like create custom integrations via PubSub, which would allow you to do things like automatically remediate some items. So say you have a bucket on one of your projects for cloud storage that somebody has inadvertently made public, you can surface that would get surfaced as a finding. And then once that finding gets surfaced, a message will be sent to PubSub, and then you can do things like, take that PubSub message and then close that bucket so that it's not public anymore. Or instead of doing something like that automatically, you can take those findings and put them into other systems, or into Jira or a ticketing system, so that somebody can pick that up and investigate later. So I wanted to just take a minute to kind of show what that looks like. This is the GCP And if you go into the command center over here, I'll actually just show that. On the right, you can click on Security Command Center. It's a little bit cut off, but hopefully you'll see the center here. Takes a minute to come up. Especially when you're live streaming. All right, we'll come back to that. So that's basically like, Security Command Center. And so like, I thought that was an important one because it's a pretty important piece of the overall set of security features that GCP has. So next we'll go to the next session and Yoshi's going to give an overview of that.
Yeah, thank you, Ian. So my first pick is Security 226, the title Getting Started with Beyond the Corp, a deeper look into IAP. So from the general engineer perspective, I've been using Beyond the Corp for a while before the Zero Trust network has been around in a cloud native era. So as a Googler, I've been using Beyond the Corp. I'm utilizing the Beyond the Corp technology for day-to-day work, and then I felt it's really convenient and then it's really useful because we do not need to use the VPN. That is fantastic because of the bandwidth to connect the required infrastructures for work. So then this session introduces how the Beyond the Corp is working. So it gives you an overview of Beyond the Corp itself, and also you can learn how to achieve those system with the Google Cloud products. So the nice thing of the this session is that it gives you example of existing technology for like work from home technologies like VPN and so forth, and then it explains how to move from those existing technologies to Beyond the Corp. So the fundamentals of the Beyond the Corp is mostly known as the Zero Trust network. And in this session, with the knowledge of the Zero Trust network, the presenter gives the components, gives the idea of the components in each required system in a Beyond the Corp, and then those are cloud identity, device verification, access context manager, and IAP. And then especially in this talk, the presenter emphasizes the IAP is a key. IAP is the most critical part of the Beyond the Corp because it controls every request, and also it controls every data for the request, network request. What I felt interesting was you can still use the IAP for non-GCP system, so you can create the Beyond the Corp system on top of GCP as a strong proxy for external non-GCP system like on-premise system, for instance. So I felt that as we are in we are living in the world where a lot of people are working from home. So this kind of technology is really on demand, requested, and it's great to learn how to achieve those kind of the beyond the COP system with the kind of with the Google Cloud product as a set of solution that you can use step by step. And also the presentation gives a demonstration of how to how to build the Beyond the COP system with the G Suite and Access Context Manager and IAP, and also session control. So it's really easy to understand how you can set up from the scratch. So yeah, if you are interested in the Beyond the COP technology, then please check this out.
Yeah, it's a really good overview of the how Beyond Corp works and like how it like kind of functions as an alternative to things like VPN. Awesome. Let's go to the next session. So the next session that I wanted to pick up and talk about was the session minimizing permissions using IAM Recommender. And this is a particularly interesting session because it focuses on IAM, which is like an important security piece, but it's also something that everybody has to touch and use on Google Cloud. But it's also something that's like very hard to kind of set up and manage over time. And so in this session, like they introduced like the IAM Recommender, which is a kind of a really interesting product, as well as the how Uber used it to take those recommendations and integrate them into how they kind of respond to those recommendations, either by creating tickets and having people, having it automatically triage them so that folks can, prioritize them, or to apply those recommendations automatically. So IAM Recommender, just as like, a full background, like is a recommendation engine that recommends like changes to your permissions on IAM to maintain the least privilege necessary. So essentially, if you give a particular user a bunch of permissions, like editor permissions on an entire GCP project, they usually don't need to use all of the privileges that are associated with that particular IAM role. So like editor, in this case, like editor has like most of the permissions on that project. And so if somebody somehow is able to take control of that person's account, they can do almost anything. And so by having less privileges, or only the privileges that person is allowed to have or needs to have to do their work, you can reduce the kind of attack surface and the risk that's associated with each person's account, or with your service accounts on IAM. So it's really nice because what it does is it says like, oh, you're not using these particular privileges, and so you can probably get rid of them. But it will also use a little bit of machine learning to say that, hey, the people that use these privileges probably also need to have this privilege. So even though you're not using this particular privilege, it will actually, for the ones that it thinks you probably need anyway, it will keep those as part of its recommendation. So it's not just saying, hey, you haven't used these ones and blanket recommending that you remove them. It will actually do a little bit of smarter recommendations for you. So that's one of the really awesome things about IAM Recommender. But the other thing that's really cool is that it gives you an API. So you can actually like use the gcloud command to like list the applications, or you can talk to it via the API and get a list of the recommendations, and then do things with the recommendations, either via your own application or via like Cloud Functions or something like that. And so what Uber did was they created a set of Cloud Functions and applications that will take these recommendations and then triage them, prioritize them, and then either automatically apply them or create Jira tickets or for their security team with the right prioritization, so that security team can take a look at the recommendations and then apply them as necessary. And so like that really cut down on like the things that they were having to do, because they were having to manage like their own recommendations and keeping them in spreadsheets and prioritizing them because they have many IAM, thousands and thousands of IAM settings, and so they need to be able to prioritize those so that they know which ones are the highest risk and which ones need the earliest attention from the security team. So by having these recommendations, they can, and having them available via the API, they can do a lot more of this work kind of automatically to help maintain a better security posture overall. So I thought that was a really cool presentation, and the folks at Uber did a really good job, and they covered a lot of the architecture of the application that they built. So I really recommend checking out this particular session. All right, moving on to the next session.
Okay, so this is my second pick, the Security 302 Advanced IAM Hacks, Tips, and Tricks for Policy Management. As Ian just touched in Security 216, so tweaking the privilege of IAM is really important to reduce the risk of the vulnerability. And then, and in this session, particularly gives you the overview and a deep dive of the API for controlling IAMs programmatically. So if you are really new to controlling the IAM roles and IAM policy from the program, not on the UI, this session is the must watch. So this session gives you starts from the overview of what IAP role is, and what IAM role is, and then what the IAM policy is. So IAP role is basically who can do what in where, and also in this February, the IAM introduced the condition. So in that sense, now IAM can handle who can do what in where on when. So this, and then all of those can be set over the IAM APIs. So given that information, now you can understand how the IAM policy can be evaluated in an organization. So IAM policy is basically evaluated in a inheritative way. So if some IAM policy is set in organization level, then that will be propagated into the really granular project level. So this presentation gives you the basic mechanism of the IAM, how our IAM policy are evaluated, and it's really it gives a really understandable example in the demonstration. And also, the nice thing of this session was that it still gives you the navigation for the useful tools to check the IAM policies. So the policy troubleshooter is one of those. So if you use the policy troubleshooter, you can easily understand how the IAM policy you set into the specific person So it gives the intuitive visualization of the IAM policy. So if you haven't used that, I really recommend to you to check that tools after this session. And also the latter half of the session was all about how to set the IAM policy from the program. It means from the API. The really important thing to note here is that policy modification always require the full set of metadata, including the existing policy setting, and then also from the version 3 of the API schema. It gives a lot of tweaking point for the IAM policy, such as the conditions for IAM role, for instance. So this session gives a really concrete example of how to program the IAM controlling system with the Python, and then it gives a demo of that. So you can, I think after watching this session, you can get the really fundamental and advanced understanding of how to control the IAM policy from the program. And then in the combination with the Beyond Corp, I believe that you can establish the really work from home friendly system on top of GCP. So if you are interested in how to set the IAM policy programmatically, please check this session afterwards. Thank you.
Yeah, this particular session was really nice to watch. I learned a ton about it, about the AI and different tips and tricks. Yeah, like definitely combining this with the other kind of new APIs like the recommender and the other kind of analytics tools that are starting to come out with IAM, like really makes it kind of a powerful set of APIs you can use to like really keep the security policies really tight. All right. The last session that I wanted to go over for Anthos clusters session, and this particular session was kind of interesting. It didn't go into a whole lot of kind of API use or whatever, but it was interesting to take a look at the authentication options for Anthos clusters and how to set that up. One of the things that was interesting was the support that we have in Anthos for auth mechanisms like LDAP and Active Directory, OpenID Connect, and Okta. And you can use all of these or multiple sets of these auth mechanisms at once, and you can use them across all of the places that Anthos can run. So like on GCP, as well as other clouds, as well as on premise. So you can kind of have a single kind of Active Directory, for instance, that you use to authenticate with your on-premise Anthos clusters as well as your GCP Anthos clusters. So that was like really an interesting thing to see how to use and set up. And so they also gave like an interesting demo on workload identity, which currently works on GCP only right now, but they're also bringing to other cloud providers and on-prem, which allows applications that run inside of your GK cluster to your Anthos GK cluster in order to actually use GCP APIs. So you can use the workload's identity itself in order to authenticate with the APIs, and then make it a lot easier to use the APIs because you don't have to deal with service account keys and whatnot and mounting those inside of your containers. You can just use the workload, the identity for the workload itself, which was pretty nice. So that's pretty much all of the sessions that we wanted to pick up. I think we don't really have a whole lot of time left to go over much else. So I think that we may have had like some questions, but I think we'll probably need to answer those online and kind of move on to the other sessions. So thanks for tuning in, and we'll get to the questions if you answered some or you posted some on the website. We'll get to those and post answers to you guys online. So next, we're going to go to some sessions. The first one is going to be by some of the engineers on the Cloud Secrets team to talk about Cloud Secrets, which is a really cool product for developers to talk to you to store and manage secrets that you use in your applications in a really nice way. And then the second session will be from Stephanie Wong about the data center security and some of the physical and important base security that goes into all of GCP itself to help maintain the security overall of GCP and help build kind of trust for users and developers. So thanks. Let's go to those sessions.
Hello, everyone. Today we are going to see how to secure your workloads on Google Cloud with Secret Manager. We have 3 speakers today, and each speaker will provide a deep dive into their respective topics. I am Sonal. I am the engineering manager for Secret Manager and Cloud KMS. I will share an overview of Secret Manager and its differentiating features. Then Sandro, the tech lead of Secret Manager, will give us a demo of Secret Manager and a deep dive into its features. And finally, Tommy will show us how to use Secret Manager with some of your existing workflows, like on Terraform, GKE, and such. With that, let's get started. We realize not everyone may be familiar with the product. So let's begin with an introduction to Secret Manager. Secret Manager exists to provide a secure and convenient method for storing API keys, passwords, certificates, and other sensitive data. Secret Manager can hold many types of data, but its primary use case is for things like API keys, private keys, certificates, auth tokens, passwords. Before moving on, it is important that we address a top question. What is the difference between Secret Manager and Cloud KMS? I also happen to be the engineering manager for Cloud KMS. So Cloud KMS is a cryptographic oracle system. Nobody, including yourself, can extract the keys, and KMS provides high-level operations like encrypt, decrypt, sign, and verify. Secret Manager is a data storage system for saving and accessing secret material. To persist a secret with Cloud KMS, you must create an encryption key, encrypt the secret with that key, and store the resulting ciphertext somewhere, maybe on a file system, in a database, or in memory. Cloud KMS does not store the secret. You are responsible for storing the encrypted ciphertext. To persist a secret in Secret Manager, you name the secret, for example, Twitter API key, and store it in Secret Manager. To retrieve a secret with Cloud KMS, the process is reversed. You must provide Cloud KMS the ciphertext you created in the previous step. Cloud KMS will decrypt the ciphertext and return the plain text value. To retrieve a secret with Secret Manager, you access the secret by name. For example, Twitter API key. If you're authorized to access the secret, Secret Manager will return the secret and its metadata. In addition to the foundational principles of any Secret Manager, we believe there are certain features that differentiate us from the rest. Let's look at them. The first one is global names. Secrets rarely differ across cloud regions. For example, your Twitter API key is unlikely to change if you move your app from US East 1 to Europe West 2. For this reason, secret names are project global resources. While secret names are global, the actual secret data is still stored regionally. Some enterprises want full control over the regions in which their secrets are stored. while others don't really have a preference. Here is a diagram to illustrate this concept. The resource URI refers to the secret my secret in the project my project. Even though the secret name is global, the underlying secret data is still stored regionally in US East 1, in US West 2, and Europe North 1. But how does the secret data end up in these regions? How can you configure the list of regions in which the secret data should be stored? This leads us to our next differentiating feature, replication. You define replication policies. Secret Manager will automatically replicate secret data to regions to maximize the availability. You can define these replication policies. Customers who don't have a preference for where their secret data is stored should choose an automatic replication policy. With this policy, Google chooses the list of regions. Customers who require data to exist only in a certain region should choose user-managed replication policy and pick the specific region or regions in which the secrets should be stored. Regardless of the replication policy choice, Google handles the replication of secret to all selected regions. You don't have to run a cloud function or kick off a nightly cron job. Google is the first public cloud provider to offer fully managed replication of secrets. Speaking of replication, another differentiating feature is that accessing secret data is a strongly consistent operation. That means you can access a secret immediately after creating it. You do not have to wait for the replication to be complete. The next feature is versioning. Versioning is a core tenet of reliable systems to support gradual rollout, emergency rollback, and auditing. Secret Manager automatically versions secret data using secret versions. And most operations like access, destroy, disable, and enable take place on the secret version. Until this point, we have been talking about secrets. But a secret is actually just a thin wrapper around a logical collection of secret versions. The secret version stores the actual secret and its state. You can pin to a specific version, or you can use the latest alias to pick the highest numbered version. Note that latest is a floating alias. So if a new secret version were created, latest would point to that version automatically. For this reason, we have some recommendations on how best to use versions. Production deployments should always be pinned to a specific secret version. Updating secret should be treated in the same way as deploying a new version of the application. On the other hand, rapid iteration environments like development or staging can use Secret Manager's latest alias, which always returns the most recent version of the secret. Lastly, access to secrets in Secret Manager must be explicitly granted via Cloud AIM. You can grant an entity permission to access a secret without granting permission to create a secret. You can grant an entity permission to view metadata about the secret without granting the ability to access the actual secret data. This is especially good for auditing. Permissions can be applied at a very granular level, for example, on the secret level. This makes it easy to adopt the principle of least privilege and separates concerns across various actors in your system. With that, I will now hand it over to Sandro. Sandro will give us a demo of how Secret Manager works and a deep dive into some of its features. Over to you, Sandro.
Thanks for that intro, Sonal. Hi, I'm Sandro. I'm the TL for Secret Manager. I'm going to do exactly what Sonal said and give a deeper dive into Secret Manager. I'm going to do that through the Google UI, the Google console, and I'm going to show a little bit of the gcloud commands. So right off the bat, let's go find Secret Manager in this UI. It's simply under Secret and then Secret Manager. I already have the API enabled. I've created an API key in the past. Here's where you see a list of all of your secrets. I'm going to go ahead and create a new secret. I'm going to call this secret, I'm going to call it secret cert. It's a bit redundant. There, it's just called cert. And here I'm going to put into the value cert content. Of course, normally you would have a cert generated and you would click on browse and upload that content. So you don't need to type it all out. Next up is regions. All secrets are globally accessible. You can, if you don't select anything here, then Google will freely replicate your secrets. If that's something where you want to go and select your own regions, we allow that, and you can select each individual region that you want your secret to be written to. And in my case, I don't have any special conditions here or restrictions, so I'm going to go ahead and just use the default value. Another thing you can do with your secret is add a label to it. This is useful for tagging things like the environment. And I'm going to say we're going to use this in prod. You can add another label of like last updated. Actually, we have audit logs. We don't need that. So I'm going to go ahead and just leave that label like so and click create secret. So here's my secret. It has one version. It has the value that I put into it. Default secret value. There you go. You access secret versions, and a secret contains many secret versions in it. We've opened up the IAM panel here. It shows that I'm the only user that has access to owner. I'm going to go ahead and add my friend Tommy here so that you can get a look at the different roles we allow for Secret Manager. If we go down here into Secret Manager, we can see that we have admin, full read write, accessor, if you just need access to that, to the secret, but nothing else. Typically like bots will use that, service accounts, that kind of thing. Version adder, if you have a rotation sort of setup, then you might just want to give it permission only to add a new version to a secret. And version manager, just creating and managing those versions. So yeah, these are different roles. I'm going to give Tommy admin. I'm going to give him admin, and a thing to note is that it's specifically on this one secret. You can set IAM policies on the secret. You can't set them on the version. So once you have a secret created, you can freely add new versions and not worry about any type of IAM policy issues. It's the same policy that's always going to be applied across all versions. But you can go and have fine-grained permissions that are different between every different secret you have in your project. I'm actually going to take this as an opportunity to turn on audit logging because that's a big feature and something that's really important for secrets. We use the default Google audit logging. The way that you turn that on is you go to IAM audit and then you go to audit loggings, and then Secret Manager shows up as an option here. There we are. Select that. We want admin read, and data write. I'm going to click on save for that. Great. And now I'm going to perform some actions in the Secret Manager UI. Those are audit logged just like any other action. Sorry about that. Security, Secret Manager. Here are my two API keys. I'm going to go to cert. Hello. I'm going to add a new version. Time to rotate. Sure, we can disable the past versions and we'll add it. So now if you try to perform an access on this version of the secret, you will get an error. It will say that the secret's disabled. You can use that to monitor whether or not certain tasks and resources happen to still be trying to access the old version. You see that the new one is enabled. I could go further and say destroy this thing, and then you can't get that value back, or I can go ahead and enable this one again. Yeah, let's enable this version. And now you can access both of them freely. It's up to you to decide how you want to retire old versions of a secret in the case that you're performing rotation. We leave this up to you. The only thing you can't undo is a destroy. So when you finally want to delete that material, you can click on destroy and we'll wipe out that data. Right. So Secret Manager admin, that's Tommy. He's the owner. Okay. We turned on logs. I performed some actions. Actually, I'm going to perform some more actions. I'm going to view this value, time to rotate. I'm going to view this value. cert content. Okay, great. Now I'm going to go and find the audit logs for it. So that's down here in logging. It's here. Logging, logs viewer. And within the logs viewer, yes, here we go. So we have down here, Secret Manager API, access secret version, cert version 1, and the user. That's me. I did it. You can see things like IAM policy, how that was set. That's also audited. So you can see that I opened up permissions. That I was the principal, there's Sandro, and then in the request, it will say that the policy bindings, that I made Tommy Murphy the admin on this secret. So yeah, we show exactly that, access secret version. You can see that I then went and accessed it. This was when I was in the UI and poking around with those things and looking at the version. So every time you do an access, it gets logged. It shouldn't be surprising. But here we're at. Logs. Nope, that's all. Okay, great. Ah, yes, there's the add secret version for cert 2, if anyone's paying attention. Great. So did all that. I'm gonna go back to Secret Manager. Right. So there's labels. Right there. Whoops, sorry. I don't have any resources selected. Right. Shows up right there. Environment, prod. Great. Next step is to show you what gcloud looks like. So for that, I'm going to use Cloud Shell, the best shell. Come up here. There you go. Right. This shouldn't come as a surprise. Let's see here. I'm going to go and click into API key. I'm going to say copy resource ID. Okay. And then I'm going to say gcloud secrets. And I'm going to paste version 2. Sorry. I'm going to say describe that. And shouldn't be any surprise there. It shows the time that it was created, that it was enabled, and the name. Actually, what might be surprising is that the value is not in there. In order to get the value out, that is a separate API call. You need to specifically call access. So I'll do that. Secrets, versions, access. And it is hiding in there. Yet another version. Oh, whoopsies. I ended up clicking on a different resource this time. I'll go ahead and change that to cert. There you go, time to rotate. Sorry about the messy output. We don't output the new line. We don't like add a new line at the end of the output. That way, if you want to do shell scripts this way, even though you should be using format, we give you the ability to do that and have the element of least surprise there. Let's go ahead and reset that. Okay, we're back there. There's one other nifty thing that you might want to know about. In the case that you're not using prod and you don't want to pin to a version and you don't have rolled out, or it's just sort of like a dev secret, there's an alias, so you can use latest instead of actually specifying a region, a version to get the newest thing. So if I do that, there we go, it still works. That's great for quick demos, for quick things. If you don't want to put a lot of thought into how to actually safely rotate and move on to a new version, you have the ability to grab and use this alias called latest. I think that's actually all that I have to say about Secret Manager. Hopefully this was a pretty good review of all the features. And I think I'm going to hand this off to Tommy, who's our expert on client libraries. And he'll show you how to actually use Secret Manager outside of GCP and how to integrate it to workflows that you may have outside of GCP. All right, thanks everyone.
Thanks, Sandro. I'd like to demonstrate some integrations with Secret Manager using this Slack application that I wrote. It's called Dog Echo. and it responds to slash commands. The slash command bark will translate the message that you write into dog. For example, if you say bark hello, it will respond with the dog says bark. If you say bark hello Sandro, it will say the dog says bark bark. Now, a secret is needed because this is running as a web server that anyone can hit. And we want to make sure that it is only Slack that is sending us the message and not just a random request from the internet. So Slack provides you with these verification tokens that you can use to verify that the request genuinely came from Slack. This is a secret that we don't want to leak so that no one else can pretend to be Slack. The first integration that I want to show you is this Terraform integration. I'm going to deploy this Slack bot by using Terraform and running it as a Cloud Run service that accesses a secret in Secret Manager with that Slack verification token. The Terraform here will create a secret in Secret Manager. It will create a service account and then grant that service account the secret accessor permission over the secret. Then the Cloud Run service will run as this service account, allowing our application here to access the secret. This application will use the standard library that Google Cloud provides in Go to read the secret values. So let's try running this Terraform. I've already cloned the repo, and we have the Terraform script here. First thing I'll try is Terraform plan. We couldn't run this because we have not yet initialized the Terraform. This downloads the Google Provider plugin, which is used to create the Secret Manager resources. You run Terraform plan. All right, that looks good. And let's create it. So here we go, creating the service account, creating the secrets, and starting up the Cloud Run service as that service account. Now, the output of this Terraform will be the URL that we'll use for that bark slash command. We can see it here. Let's try opening it. All right, it gave me this error, no secret loaded. That's because I wrote the application to periodically load the secret value, and we'll see if we go to Secret Manager that we have the secret here, but there's no versions for the secret. So the application right now is unable to load the secret value. In Terraform, you can actually write the secret values directly, but doing that, your secret will end up in the Terraform state file, and I didn't want to do that for this, this example. So I'm going to have to add the actual secret data manually. All right, I click add version. I need to go back to the Slack website, get my verification token, and write that into Secret Manager. Since I wrote the application to periodically reload the secret, I can just try refreshing the page here and seeing if it got the value, which it did. So now I get this other error message called Slack verification failed, and that's just because we're not providing any authentication to this URL, and so we are not Slack, and so the server is rejecting our requests. So the last thing that we need to do to fully configure this is to go back to Slack and tell it to hit the correct URL for our slash command. All right, success. And so let's try it out. Slack, say bark, hello, and it said bark. If I say bark, hello Sandro, it says, the dog says bark bark. So great. We've used Terraform to create a secret, set the appropriate permissions on the secret, and to deploy a Cloud Run application to service our Slack application. So the next thing that I want to show, or the next integration that I want to show, is this GitHub Actions workflow integration. So I have the repo here, and I have this GitHub action where I want to actually build and push a Docker image of my Slack bot to Docker Hub. Now, pushing to Docker Hub is going to require a username and password. And there may be a number of systems that you need to interact with in your build or deploy pipelines where you need some sort of credential to talk to a third party. Here, I will show that we can use Secret Manager to fetch these credentials. So let's edit this to, instead of hard coding this hunter2 password, we're going to replace it with a secret from Secret Manager. Back at Secret Manager here, see I have this Docker registry token secret already created. And so let's fetch this. Let's see. I'm going to edit the steps of my workflow with this GitHub Actions get Secret Manager secrets step. I'm going to get a secret called internally here, I'll call it Docker token. And then I need to provide it the resource name to fetch. So I'm going to say the projects, my project number, secrets, Docker registry token. Let's do the latest version. Version/latest. Okay. Now I need to reference this secret in this step. For that, we can do steps, reference this secret step. This will create an output with a Docker token. So outputs Docker token. And now it will replace what we have pulled here, the value of that secret, for this password value here. So let's commit this change. And now we'll actually wait for the actions to run. You'll notice that I have set this up to runs on self-hosted. I'm actually running the GitHub action on a GCE instance within my project. So we see that GitHub has already started to execute that action, and it will be running on a GCE instance in my project that already has permissions to access secrets in my project. The advantage of doing this is that there's no need to export a service account credential or to write any secrets to GitHub directly. My GCE instance here will just consistently poll for new actions to execute, and then from the GitHub repo, execute those, and then those actions will run in the context of this service account, which has permissions to access my secret. So we can see that we are building the Docker image here. It's building my Go code. So we'll wait for that to finish. Okay. And then, yeah, it looks like it has successfully pushed to Docker Hub. So let's go over to Docker Hub here. I'll refresh this page and we'll see, yep, there's a new dog echo image published just a few seconds ago. So great. Now has our image. So we've gone over this Terraform integration, which is a great way to configure and manage policies over secrets. And we've gone over a GitHub Actions integration. That's a great way to manage secrets for your build and deploy workflows. We also have other integrations such as Java Spring Platform integration and a Kubernetes storage provider that allows you to access secrets through a temporary file system mount instead of using the API directly. But those demos will have to wait for another time. Thanks for watching.
Hey everyone, my name is Stephanie Wong, developer advocate at Google Cloud, and you may have seen some of my videos. I created a bunch of online content about security, including a video on data center security recently. Thanks so much for joining week 4 of Google Cloud Next 2020. This week is all about security, which is a huge topic because, as you know, hope is not a strategy when it comes to security. It takes best practices, proactive measures, and additional measures at all layers of the stack, and it even ingrains itself in a company's culture, people, and organizational design. So today I'll be talking about what you get as a Google Cloud customer natively when it comes to security, especially at the infrastructure layer. So how can Google Cloud help you and organizations with their security? So first, we provide protection from threats through a secure foundation that is core infrastructure that's designed, built, and operated with security in mind. Second, we provide customers with a constantly expanding array of controls that they can use to help meet policy, regulatory, and business objectives. Third, we work to meet our compliance responsibilities and provide capabilities to make compliance easier for you. First, let's talk about the protection that you get from building on our infrastructure foundation. Our infrastructure doesn't rely on any single technology to make it secure. Rather, we build security through progressive layers that deliver true defense in depth. Our hardware is Google controlled, built, and hardened. Any application binary that runs on our infrastructure is deployed securely. So we don't assume any trust exists between services, and we use multiple mechanisms to establish and maintain trust. Our infrastructure was designed to be multi-tenant from the start. All identities, users, and services are strongly authenticated. Data stored on our infrastructure is automatically encrypted at rest and distributed for availability and reliability. Communications over the internet to our cloud services are encrypted as well. The scale of our infrastructure allows us to absorb many denial of service attacks, and we have multiple layers of protection that further reduce the risk of any denial of service impact. And our operations team detects threats and response incidents 24/7, 365 days a year. We've also written a white paper on our infrastructure design that goes into all these areas in way more detail than I can offer right now, so I encourage you all to check that out. And other cloud providers might describe a similar stack of capabilities, but the way that Google Cloud approaches many of these is very unique, which you'll hear more about in a second. Let's start by zooming out to focus on our hardware and infrastructure, that is our data centers. So I had the chance to visit a data center last year, and I made a video about my experience that you should all check out. The link is going to be at the end of our presentation today. And this was a super big project. It wasn't easy to get any approvals or even step foot inside the premises. And in my job at Google, I spend my days working with developers. Our data centers are crucial to the work that they do, but most have never actually set foot inside of a data center. In fact, less than 1% of Googlers even get to set foot inside of our own data centers. And I was very determined to make a video because for close to 2 decades, Google has designed data centers from the ground up. And security has surfaced as one of the most critical elements of our data center's DNA. It's part of our commitment to keep our customers' data safe, and Google Cloud also meets more than 45 regulatory requirements globally. So speaking of our regulatory requirements and audits, our products regularly undergo independent verification of their security, privacy, and compliance controls, and we achieve certifications and attestations of compliance or audit reports against global standards. So what that means is that our data centers, infrastructure, and operations are all examined by an independent auditor, and they look at all of these factors, and these certifications include the most widely recognized, internationally accepted independent security standards like ISO 27001 for security controls, ISO 27017 for cloud security, and ISO 27018 for cloud privacy, or SOC 1, 2, and 3. These certifications help us meet the demands of industry standards like CSA STAR and PCI DSS, as well as many other regional standards as well. So what does it take to actually meet these standards? Well, upon my visit, I learned that Google employs 6 layers of defense to thwart unauthorized access. And so I'm here to give you my firsthand account of what that was like to move from layer 1 all the way to layer 6, the deepest part of the data center where data actually resides. And trust me, it's not something taken lightly at Google, but I was able to learn about the precautions taken to keep our data safe 24 hours a day, 365 days a year. So I got this really special sneak peek into it, and I'm going to share that with you today. So let's start with layer 1. So that is really just the secure perimeter of a data center. Basically, it means the property boundaries, and that includes all of the signage and fencing around the property. But things really start to get interesting when it comes to layer 2, also known as the secure perimeter, and that includes the actual main entrance gate. So I started my journey by driving up to the gate, at which point I needed my credentials and identity checked. Even before stepping foot into the property boundaries, I was already on an access approval list. So I'm sure you've heard of this. The least privilege protocol is the idea that someone should have only the bare minimum privilege necessary to perform their job function. So if your least privilege is to enter layer 2, then you won't have luck moving into layer 3. Each person's access permissions are checked at badge readers starting with layer 1 and progresses more stringently at layer 6. These exist at every access point at the data center facility. Authorization measures happen everywhere using this protocol, and this is something that we employ not just in the data center, but is the best practice we always recommend for how you set up your organization resources and data on Google Cloud as well. So layer 2 has a lot of security features ranging from smart fencing to overlapping cameras to 24/7 guard patrols and more. So yeah, there's actually a lot more technology and operations going on behind the scenes here than meets the eye. So from the time that you're on site, they already know that you're there. And what I found interesting is that they were able to do correlation analysis of where you've been on site through cameras, badge access tracking, etc. And then there's also guards in vehicles and some guards on foot. As you can see here, there's also the vehicle crash barrier system, and that right there, as you're seeing, and this is designed to stop a fully loaded truck or vehicle from crashing through the front entrance, which is pretty cool. This particular black fence that you see here is an anti-climb fence. So these spikes are pointed outward, and this is really because they want to make it very hard for you to get over that fence in one piece. It's also equipped with fiber. So the technology tells the data center security operations if someone's near the fence or touches the fence. They also use thermal cameras as well as standard cameras so that they're able to see video footage at night just as clearly as they can during the day. Every camera there overlaps in the area that it covers so that there are no blind spots anywhere around or in the data center. Now you probably are wondering, what if somebody skydives into the property or digs under the ground under the fence? And trust me, they have enough coverage of the property and the area that they will detect something coming into the property or motion that's occurring near the fence. So these are not only just physical safeguards, but they act as a big deterrent to anyone even thinking about trying to forcibly come inside. And of course, more obstacles await them inside if they do happen to make it past layers 1 and 2. We have additional operational monitoring happening in any case, and that will alert more guards to take action if they detect something. So layer 3 is building access. So in this case, I was able to actually enter the lobby. But just so you know, this is nowhere close to the actual data center floor. That's still a few more layers deep. So let's say that you've gotten through the gate, you've come into this secure lobby. You must have your card or a form of identification, which is checked by a receptionist to make sure that you're actually on the access control list. But what happens if you happen to lose your card or you don't have it that day of? So for that reason, biometric scanning is also employed. So yes, I actually had to get my irises scanned, and it did feel like I was sort of on this top secret Mission Impossible mission, or maybe Ocean's 11. But once I did that, and once I was taken care of, another rule exists at the data center that prevents a vehicle or an individual closely following another to gain entry into a restricted area without a badge swipe. So if the system detects a door is open for too long, it immediately alerts security personnel, and any gate or door must close before the next vehicle or person can badge in and gain access. So you've probably seen dual authentication when you try to sign into your account or you're given a one-time password sent to your phone. So we take a very similar approach to this at the data centers to verify a person's identity and access. At some layers at the data center, you're required to actually swipe your badge and then enter a circle lock or a tubular doorway, which you're seeing here. So you actually walk into this special half portal that checks your badge and scans your eyes to gain access to the next layer of the data center. And this prevents anyone from following you through because only one person is allowed to enter that circle lock at a time, and the back shuts before you're able to open the next door. So it really did feel like I was, in a movie of some sort or a sci-fi movie. And then something that wasn't shown in the video actually is that the facility loading docks are another special section of layer 3 used to receive and send shipments of material such as new hardware. So truck deliveries from vendors must be approved for access to layer 3 to enter the dock. And then for further security, the loading dock room is physically isolated from the rest of the data center, and guard presence is required when a shipment is received or sent. And then I got super lucky when I was there and got to witness a shipment actually being made of new servers being delivered. And it was very interesting to watch because the truck was backing up into the loading dock room with guards communicating with one another to allow them in safely. And then, of course, in order for them to even get to layer 3, they had to have already been on the access list through layers 1 and 2 before arriving at layer 3. So guards checked everything before letting them into layer 2 and subsequently actually opening the garage door to let them back up into the room. And then out came the fresh new server racks one by one. Once unloading was complete, the vendor was able to leave and hardware operations then began to unload into layer 4. And in order to do that, they had to make sure that anybody who's actually physically moving servers into layer 4 are also on a special access control list, and they must badge themselves in one at a time with hardware and move that into the actual data center. As I said, in order to move from room to room, you have to let the door close behind you. Then the next person has to be authorized to go through individually. So that was something to get used to. You're probably thinking of your favorite movie, wondering if supply chain gets intercepted at any point. But again, there are additional checks that happen for this potential risk, and we have tested for many possible risk scenarios, which I'll talk about later. So layer 4 is once you've actually entered the data center itself, past the lobby or past the loading dock, and this includes a very important part of the data center security. It's extremely crucial, and it's called the Security Operations Center, or SOC, which is a hive of activity that is monitoring the data center 24/7, 365 days a year. So the doors, the cameras, the badge readers, iris scans, everything is monitored from here. Anyone on site at the facility will have their own movement patterns tracked throughout the property via their badge and biometric scans at entry points and doors, along with camera footage. If a door is kept open for too long, for example, or correlation analysis finds their presence is in an unauthorized location, alerts will be sent to the SOC instantly, and this acts as the true brains of the security system overall. So if there's anything out of the ordinary happening, they have to be able to pick this up here. The SOC of all Google data centers are also designed to roll up to a regional SOC. So that means if an on-site SOC were to be disrupted due to an event such as a natural disaster or emergency building evacuation, monitoring is going to roll over to a regional SOC. SOCs sort of act as the Center for an Emergency and Safety Response in addition to security responsibilities. So these SOCs monitor and respond to alarms at all facilities and are constantly tracking local and global events that could impact operations at our data centers. So think of this like a high availability for physical operations at our data centers and for security. And that really means that it's a high availability for logical security as well and data protection at all regions. So now, getting to the juicy part, layer 5 is the data center floor. So this is where servers and network equipment that power Google live. Security in this layer is one of the most, if not the most, highly restrictive, as it's where the data actually resides. This means, I needed to enter a circle lock, get my irises scanned and badge checked once more, and then once in there, I was accompanied by additional guards In every space that I walked, there was always a guard with me, and I was also being accompanied and led by our VP of Global Data Centers, Joe Cava, who took me around and, kind of told me about all the operations and what I was seeing, the network equipment, the fiber. It was just really an amazing and interesting place to be. As you expected, it's super loud inside, so we're kind of screaming at each other. But he was telling me that, only hardware operations personnel, security professionals, and key people granted access on an as-needed basis can enter. Access is limited to the time required to complete the necessary job function. So you can only be there for a certain amount of time before, your authorization is timed up. So this is truly an as-needed only access area, meaning that only the technicians and engineers that have to be there to maintain, upgrade, or repair the equipment are ever allowed to be there. And this layer is protected by a circle lock, security staff, and badge protected door. The data center floor, yes, features laser beam intrusion detection, which I know you probably were all hoping for. So additional cameras are placed throughout the area in addition to these other security measures, while security staff monitor the data floor at all times. And if you're wondering, Googlers do not have access to the data, even those that are technicians or that are doing repairs or upgrades, only unless you have authorized it for a technical issue. Like, for example, if you had a support issue, and they wouldn't even be physically located necessarily at the data center, but only in those cases where you are explicitly allowing them or authorizing somebody to access data for support or a technical issue can that occur. So yes, at the data center itself, technicians have access to the devices, but the data at rest is encrypted and you can issue and keep your own encryption keys as customers. And then, fun fact, the camera crew that I was with had to actually leave their equipment in a secure storage area in layer 5 every night, unless they wanted to take it out and go through all these additional security protocols. So for example, if they wanted to take it with them after filming, every hard drive had to get checked for encryption and any instances of unauthorized data. And normally you can't even walk out with any piece of metal. Metal detectors are required upon exit. Layer 6 is disk destroyal, or as I like to call it, hard drive graveyard. I swear that I could hear the voices of hard drive ghosts whispering in my ear, or, just like seeing all the shredded pieces was kind of ominous to me. But Google does employ a really strict equipment chain of custody monitoring, and that means that we meticulously track the location and status of all equipment within our data center. This means we track the location and status of every hardware from acquisition to destruction using barcodes and asset tags. These tags are scanned throughout a hard drive's life cycle in a data center from the time that it's installed to the time that it's removed from circulation. Tracking hard drives closely ensures that they don't go missing or end up in the wrong hands. We also make sure that hard drives are properly functioning by doing frequent performance tests. If a component fails to pass a performance test, it's deemed no longer usable. So to prevent any sensitive information from living on that disk, we remove it from inventory to be erased and destroy it in layer 6, or disk erase. And disks that enter layer 6 will go through a secure two-way locker system, which you're seeing here, allowing only authorized personnel to retrieve the disk in layer 6. So you see here, one person that gives the hard drive can only access layer 5, and only the person here in layer 6 can retrieve it and enter layer 6. Then when a hard drive is erased and retired, the disk erase formatter will use a zero filling method that wipes the disk data and replaces each bit of data with zeros. If the drive can't be erased, it's stored securely until it can be physically destroyed. As you can see here, it's pretty impossible to recover any data from these drives. And if you did try to take anything out with you, as I said, metal detectors and video surveillance ensure that all personnel exiting the data center halls are properly checked to prevent unauthorized equipment from ever leaving the floor. So for this reason, leaving layers 5 and 6 is arguably more difficult than entering, because as each person must exit through full metal detection and detailed examination. Fun fact also, Google Cloud employs a security testing program where undercover actors in our employ attempt to bring hardware out of the data center. And this helps to constantly test and improve our physical data center security techniques. And Urs, our SVP of Technical Infrastructure, who basically built infrastructure here from the ground up 21 years ago, even shared that we run dozens of drills a year, paying unannounced skilled adversaries to try to get past controls by any means necessary, except violence. And this includes fake badges, social engineering, fake UPS trucks, ladder trucks to get over the fence, people hidden in trucks, attempts in thick fog, everything. And we usually win. After every attempt, we run a blameless postmortem to improve and make the next attempt harder. And that's what I call a security culture. And I just interviewed another chief information security officer recently on my podcast, who also agrees that security must be a part of a company culture with a dedicated team for security. And then you really have to embed that culture among everyone else who is not even a part of that dedicated team. Whether talking about software or infrastructure, a layered approach at the user, application, and infrastructure level are imperative because there's no silver bullet to security. So on top of employing security at all layers of the stack and getting all hands on deck from developers and infrastructure teams, it's important to constantly test your protocols and systems by running through all possible scenarios consistently. And this is what also supports our compliance with global regulations. While this outlines Google's layered security approach at a data center, it is by no means an exhaustive indication of the technology and professionals that we employ. Our defense in depth approach expands our ability to mitigate potential vulnerabilities at other layers of our stack. Our hardware infrastructure is custom designed by Google, from chip to chiller, to precisely meet our requirements, including security. Google's servers and their OS are designed for the sole purpose of providing Google services. And our servers are custom built and don't include unnecessary components like video cards or peripheral interconnects that can introduce vulnerabilities. The same goes for software, including low-level software and our OS, which is a stripped down hardened version of Linux. And then on top of that, we design and include hardware specifically for security, like you see here with our Titan security chip. This custom security chip that we use to establish a hardware root of trust in our servers and peripherals. And we also build our own network hardware and software to improve performance as well as security. This all rolls up to our custom data center designs, as you've already seen through all these multiple layers. So basically, all in all, understanding provenance from bottom of our hardware stack to the top allows us to control the underpinnings of our security posture. Unlike other providers, we have greatly reduced the vendor in the middle problem. So if a vulnerability is found, we can take steps to immediately develop and roll out a fix. And this level of control results in a really reduced exposure for us and all of you as our customers. Many other providers also offer optional encryption capabilities. Our approach is a little bit different. Communications over the internet to Google Cloud require properly terminated TLS connections. Our data reaches our infrastructure. It's encrypted at rest. Once the data reaches our infrastructure, it's encrypted at rest by default with no extra effort required by customers. And we encrypt data prior to it being written to disk. Encryption is inherent to all of our Google's storage systems rather than added on afterward. It's first chunked, then broken up into pieces, and each chunk is encrypted with its own encryption keys. Each encryption key is wrapped using an encryption key, and the encrypted chunks and wrapped encryption keys are then distributed across Google's storage infrastructure. If a chunk of data is updated, it is encrypted with a new key rather than by reusing existing keys. When data needs to be retrieved, the process repeats in reverse. As a result, if an attacker were to compromise an individual key or gain access to storage, they would still be unable to read customer data. They need to identify all data chunks in an object, retrieve them, and then retrieve the associated encryption keys. Some of our services also offer options for customers to supply or manage their own encryption keys, and we have multiple white papers on that so that you can check that out. Another key thing to note here is our ability for you to update infrastructure without disrupting customers using technology called live migration. So that means that updates add functionality, but from a security standpoint, they also are required to patch software vulnerabilities, and no one really writes perfect software, so this is a constant requirement. A perfect example here is the Spectre and the Meltdown vulnerabilities. They were discovered by researchers on our Project Zero team, and Google helped coordinate an industry effort to fix them. So if you were a Google Cloud customer, you barely had to pay attention. it was just fixed and there was no interruptions or downtime. It was updated again when the performance patch was actually rolled out. And in fact, we didn't even have a single call to support as a result of these rollouts. So live migration is the technology that enables this possibility for us to be able to update without any disruption to you. When you think about a security program, there are many areas of responsibility, like securing infrastructure, securing the network, securing data, applications, and then managing identities and access, and also securing endpoints. There are also an ongoing process for security operations and governance, risk, and compliance management. So at Google Cloud, we provide capabilities across GCP, G Suite, and connected devices that cover the entire stack. So one of the other things that we launched last year was Security Command Center. This is the canonical security and risk database for Google Cloud. And it includes a risk dashboard and analytics system for surfacing, understanding, and remediating Google Cloud security and data risk across an organization. This means from the dashboard, you can uncover common web application vulnerabilities like cross-site scripting or outdated libraries in your web applications on App Engine or Compute Engine, GKE. And you can also detect threats and use logs running on Google Cloud or detect common container attacks like suspicious binaries or reverse shell. Another capability is going back to giving you control over when Google can access your data. We also launched a service called Access Transparency, which is a technical control. And what that allows us to do is produce logs anytime a Google administrator needs to enter needs to actually enter a customer's tenant to perform something. So whether it's a request or maintenance, we show technical evidence of that every time, and it's immutable. So we were actually the first in the industry to do something like this, and it's available now so that you can control what types of access that you are going to permit. So for example, maintenance is okay, but support's not. Or it's okay for a given set of environments. All in all, at Google Cloud, we provide capabilities and assistance across GCP, G Suite, and connected devices that cover the entire scope of the responsibility, and we're continuing to expand this set of capabilities to meet customer needs. So while we are maintaining our infrastructure and many layers physically or logical, we provide you with your own controls to maintain those best practices and proactive measures within your environment, like Security Command Center and Access Transparency. If you want to watch my video going behind the scenes at a data center and going through these 6 layers, check it out at the link here at the bottom here. And be sure to check out the sessions that we'll be releasing this week on Next OnAir and the following weeks. And go ahead and take a look at the showcase demos page. I worked on several of them, including demos on e-commerce, AI, ML, serverless apps, and more. And give me a shout on Twitter or any of my social pages, and I'll definitely give you a response back to any of your questions there. Other than that, enjoy the rest of Next, and thanks all again for joining this session.
All right, so that was the last of the sessions for the Cloud Talks by DevRel. I want to thank my colleagues, Yoshi, for joining me, as well as Sandro and Stephanie and all of our speakers. Hopefully you got a good idea about what security capabilities GCP offers you in terms of APIs and features and products, as well as what you get essentially for free, essentially without any effort. Things like the data center physical security, things like the encryption at rest on disks that Stephanie mentioned. If you haven't seen her video is extremely well done, and so I definitely encourage you to go check that out. So next week we'll also be doing continuing this series of Cloud Talks by DevRel, and so check back next week for new content, and we'll see you then. So thanks, and see you next time. All right, thanks.